All right, 4.1, the vertex form of a quadratic function. When we're looking at the vertex form of a quadratic function, we have to remember that the equation looks like f at x equals a x minus h squared plus k. And that's where the vertex is hk, and the a tells us some information about the graph. If a is greater than 0, i.e. a is positive, what we're looking at is the graph opens up and looking like a U-shaped curve, and the arrows are pointing in an upwards direction. If a is less than 0, that means a is negative, the graph opens down. So that looks like an upside down U, and the arrows are pointing downwards. Another thing to note is that the vertex will end up being a minimum value if the graph opens up. So the vertex would be down here, and that would imply that there's a minimum value. And when the graph opens down, the parabola opens down, you're looking at a maximum. The vertex is a maximum because, again, it's the very highest point that it reaches when the graph opens down. Now, example 1. Determine the direction of opening, the axis of symmetry, the optimal value, and the vertex of the quadratic function f at x is equal to 3 times x minus 5 squared plus 7. So what we have to do is fill in all this information. So a is equal to 3. So what does that tell us about the parabola? Well, if a equals 3, that means the a value is positive. And because the a value is positive, we know the graph opens up. Now, x equals 5, so in here is the axis of symmetry. X equals the opposite, the number that's in the brackets. X equals 5. Well, that is our axis of symmetry. Next part is the optimal value. What is that? Well, that's the highest or lowest point it reaches, i.e. the maximum or minimum point it reaches. In this case, because the graph opens up, we're looking at a minimum. What is the minimum value? That will be the y value of the vertex, the k. So it's a minimum value of 7. And then finally, we need to know the vertex of the quadratic function. The vertex is going to be 5, 7. And that's our vertex here. So we've answered every part of this problem that's listed here. Now, moving on. Example 2. And this is taken from page 205, number 9D. You're asked to determine the equation in vertex form of this particular parabola. You're given the vertex, which is great. That gives us our h and our k. And we're given a point. We need to figure out the equation of this parabola. How are we going to do that? Well, what we need to do is take the vertex form, and we're going to plug in information. For example, we're going to plug in -1 and 4 for h and k, and the point 1, 0 for x and y. And we're going to plug it into the vertex form of the parabola. When we do that, we get 0 equals, now again it's 0 because it's y equals, y is 0, so 0 equals a x, x is 1, minus h, so minus -1, which makes plus 1, squared, plus k, so plus 4. And we plug it in and solve for a. We get 0 is equal to 4a plus 4. Bring this positive 4 over to the other side. We get -4 is equal to 4a. A is equal to -1. Therefore, the equation is y equals -1, which we do not put the 1 there, folks. We do not put a 1 here, but we definitely put the negative sign, negative, bracket x plus 1 squared plus 4, because the h and k become numbers inside the equation. The x and the y stay as variables. Okay, let's look at another example. Example B. This time we're finding the equation of this particular parabola. How are we going to do that? Well, easily done. We need to sub -3, 5, 4, h and k, and we need to plug in -5, 1 for x and y, and we'll plug it into the equation y equals a x minus h squared plus k. And we plug it in and we get 1 is equal to a x, which is -5, minus h, so minus -3 is plus 3, squared, plus k, so plus 5. We find the value is going to be 4a plus 5. -4 is equal to 4a. A is equal to -1. So again, we see that a is equal to -1. Folks, it's not always the case, but it is true in these two cases. So the equation is going to be y equals negative bracket x plus 3 squared plus 5. And that is our equation for this particular parabola. All right, folks. Well, that's the end of the video. Have a numerical day. Take care.